Alrighty. So welcome everyone to our Onshape class. So I come from FTC team 21229 quality control. My name is Eric Zhang, and let's get on the presentation. So I wanted to make a little bit of introduction about our team. Well, our team, FTC team 21229 quality control, is a community-based first tech challenge team. We operate around the general Bellevue area. We are the 2022 to 2023 FTC World Championship winning alliance for power play. We were also the 2022 to 2023 FTC World Championship Innovate Award recipient.
Wait, what? It was what?
Wait, what? We are the 2022 to 2023 FTC World Championship Innovate Award recipient. Alrighty. Well, I'm sorry. So 2024. Okay, so this year we are the 2024 FTC State Championship winning alliance, and we will be progressing to Worlds later this year. Very exciting. So, why should you learn CAD? Well, CAD is well, we use CAD for 3D printing and for CNCing machines, which is kind of like 3D printing, but which is like a machine that cuts metal, basically. So it's like 3D printing, but instead of plastic with metal. And we can use this to make, we currently use this to make over 15 different parts for a robot. The advantages of CAD is that it allows for us to quickly iterate through many different design ideas. As you can see in our images, where we can model our individual components far more easily than, say, building them by hand and by using, hand tools to physically make a model. We use a combination of Go Build It and custom CNC and 3D printed parts. This helped us to immediately test with our Go Build It components and improve our design with custom parts. So here's our agenda. First of all, I will go and give you an introduction to Onshape. Then afterwards, you will be able to go and create a custom parts through the example of creating a custom battery box. This battery box will be the, well, in FTC, you have a robot, and the robot is powered by a battery, and this battery box is meant to hold the battery in place and to prevent it from collisions or from moving. And if there is time at the end, then I will also teach you how to assemble a basic drivetrain. So if you have any questions, please ask me in the chat. I'll try to answer through the chat or through any type of break time or any or at the end of the meeting. Again, don't be afraid to ask questions. So what is CAD? Well, CAD stands for Computed Aiding Design. CAD software is commonly used to aid the design of parts and assemblies in engineering. In FTC, CAD is used to make 3D assemblies of robots and design custom parts. CAD is beneficial for multiple reasons. First of all, CAD prevents a lot of preventable problems, such as spacing issues. It will save you time when you discover and fix problems in CAD before you build your robot. For example, before you go and grab some parts and try to place them together into a robot, if you model them and assemble them in CAD, something that you will hopefully be able to learn today if time permits, you can go and see much more readily if there is a problem, or if it will all fit together in the way you think it will. Furthermore, CAD is a professional tool used in many STEM fields. Having knowledge in CAD will help benefit your future career if you study and work in the fields. Various fields include engineering, given robotics, material sciences, biotech, and a variety of other engineering fields. If you want to create 3D printed or machine parts, you will need to know CAD in order to go and design such parts. So, what is Onshape? Well, Onshape is a fully featured CAD package. It runs entirely on the cloud, and there's no need to download anything. You can run on any computer. It has iOS, iPadOS, and Android apps as well. Onshape is one of the best collaboration workflows in the industry. Onshape allows multiple people to work on the same document at the same time, and allows users to follow each other and see each other's user screen. You can join Onshape team to collaborate on designs. Onshape also has FeatureScript, a programming language where you can write custom features. The community has created very many useful feature scripts which you can completely use for free, helping you easily model complex features. If you're just starting out with CAD, or you don't have powerful computers, Onshape is a good beginning software. So, first of all, for anyone who's watching this, it's recommended that you have a mouse on Onshape. To tell you the basic controls, the right mouse button will allow you to go and rotate the screen. Panning, which is control right, or drag the middle mouse button, will allow you to pan. And scrolling the wheel in and out will allow you to zoom. And if you have a touchpad, you can rotate 2-finger hold and drag. You can control 2-finger swipe to hold and drag, and 2-finger swipe to zoom.
Onshape?
Yes, I believe it might be useful if I share the link with you. So let me go and find out the so let me share the website link with you, because you will need to create a free account with Onshape for you to be able to participate in this lesson, unfortunately. So I hope I've shared the account. If you don't have so I already signed in since I already have an Onshape account. Oh, okay, AI companion. So if you can create a free Onshape account, I'll give you time to do that. That would help you a lot. And yeah, from there I can help you navigate it. So if everyone in the meeting could please create a free Onshape account. Let's see. Oh, let's see here. Sorry, I didn't realize I was. Oh, okay. Oh, no worries, then, Ethan. But anyways, everyone, please use the link I posted in the chat to sign in and create. And if you don't have an Onshape account already, create an Onshape account. When you're ready, when you've gotten to this page with just the opening lobby page, do tell me in the chat so I know when to go. What CAD system should I be most familiar with? Well, this kind of depends on what type of system you're using. Generally, we like to use Onshape because it is well, first of all, it's free, so it helps with our budget. It is a question on this. It doesn't really matter. This is just that's just a survey for Onshape. Just answer it however you'd like. It's just in order to sign up for free. It does require these types of things, fortunately. Well, when you're done and you've managed to get onto the home page, please do tell me. It should look some bit like this, except it won't have all these documents and files and whatnot. Can we have something 3D printed for our project as a model? I can bring you up a 3D printed object if you'd like. Will that work? Because we don't actually have the plastic to be able to 3D print every single well, I'm not sure if I understand this correctly. So are you asking us to 3D print what you create in this lesson, or do you just want a 3D printed example? What should our default units be? 3D print. Okay. The default units don't actually matter, since I will specify the units, but later. But let me see later in the PowerPoint. Millimeters. Okay. Yep. Should be default unit. That's because most machine parts are generally use millimeters because it's in the international unit. Well, anyways, go give me a second. Let me go grab something 3D printed for you. So, I'm sorry that this is the only simple thing I have lying around, but I don't know if you can see this very clearly, but this is just a simple button I 3D printed. Designed this in CAD, and oh yeah, it's just a button. Just can help you do what you can do. Well, so I assume can you hear me? Yeah, okay, great. So I assume most of you at this point have managed to get onto this lobby screen. If you could say, then please tell me by just unmuting yourself and just telling me, or you can just say it in group chat. Oh, okay. Well, this is just a button. This doesn't have anything to do with the lesson. This is just to this is just for demonstration purposes of what you can do with CAD. Great. So button. Well, anyways. Oh, thank you. So now your first step. Oh, well, hopefully you can get it fixed. Not too. Well, if your 3D printer smearing things around, it may have something to do with the temperature controls you have. But that's aside the point of this. That's aside the scope of this lesson. So first, go to the top right corner and click Create.
My internet is crazy.
Oh, well, go to the top left corner and please click Create Document. As you can see. Then afterwards, you can just name the document. So I'll just name it battery holder. This name has absolutely nothing to do with the and then hit create public document. This name has nothing to do with the actual CAD. It's just to name the file. So everyone got that? So I think it would be beneficial if I demonstrated how to use the camera, since it's rather difficult. It took me a while first time. So in order to rotate it, you go and hit right mouse to rotate the thing. And by the way, this little cube you see in the top right corner is helpful for letting you understand how you're rotating it or how you're moving or your rotation. If you click to any of these faces or any of these side ones, it'll automatically level it out for you. So, like for example, if you always want to look at the top face, then if you click the top cube and just hit top, it'll perfectly center it for the top face. So you don't have to fiddle around with rotating this. The next one is pan, which is control right. Which is control right to do that, which it moves the camera around. Or you can just hold down the middle mouse button. This also does it. And zoom, which is a scroll in, scroll out wheel. So make things bigger or smaller. Great then. And this is touchpad controls in the bottom right corner. So, okay, well, this is the one for creating a new file. Taught you how to do this, so fun. So the first important part of our 3D printing process is to create a sketch. Then afterwards, you will then use basic on-chip tools and features to go and turn the sketch into a 3D printed model. We will usually create 3D minute parts in the Parts Studio tab, and then to assemble the multiple parts into something larger, you will go to an Assembly tab. So to create a sketch, select the sketch tool, which has a pen and pencil icon in the top left corner. As you can see on my screen, it's here. You can also use the key command Shift S to create the sketch. Then afterwards, it'll ask you for the sketch plane, where you want your 2D sketch to be on. So for now, choose the top sketch plane for now in order to make this easy to understand. Again, if you have trouble getting to the top sketch plane, look at the cube in the top right corner, and you can use these arrow signs, but basically manipulate it until you have this manipulate until you get to the top side of the cube, click the top face, and then now you can click the top plane. You should also clearly label the plane as top. And now that you've clicked the top plane, you can begin sketching out your design. Hope everyone's following this so far. And again, if I'm going too fast, just tell me in the chat. So now we have a sketch. Now, press the top face of the cube to look directly at the sketch, as I've already told you. We'll have a lot of tools to create parts, so let's go over each of them. So first, okay, and these are the ones we will cover in this current project. The line, the rectangle, the circle, the offset / slot, linear / circular pattern, dimension, and constraints. So here's the exciting part of this all. Here's the project. So I will show you how you can use this in a more practical sense than just me lecturing on about all those potential uses. So this will be so let's create a battery box then. So first of all, create the rectangle by using the corner rectangle tool based on the battery dimensions. I'll text you the, okay. Okay, so if you joined late, basically we went into Onshape. We've created a new document. We've then created a sketch. We've then after creating a sketch, we're now going to show you how you can build a battery box. I hope that's a good summary. Yep. So for the first part, I'll just put these dimensions into the chat. 9.5 plus 4. 13, 5.5 plus 4. Alrighty, so go down to the arrow and select the corner rectangle button. As you can see, you don't have to click the arrow. These allow you to have more options, but the default is just corner rectangle. And click 2 points here plane. And you can then stretch out a rectangle. Now, as you can see here, now I've just created a simple rectangle. It'll ask you for your dimensions. So in order to alter the dimensions of the cube, there are 2 ways. First of all, you could alter them by creating it, where I'll teach you this trick to make it simpler on you, which is just you can just use this dimensions button, which I think can be accessed using D, which is here. If you click this, you can now specify what dimensions you want it to be in. My workspace units is not correct, so millimeter. Okay. Yep. If you're curious, your workspace units should be in a millimeter as your default length unit. So if you click D, I'll sketch. Okay, and if you're curious, you can always just double click this part next to on the left side in order to re-access the sketch. So you then will type in the 2 dimensions I've posted in the chat, or you can just look it off the PowerPoint, which is 90.5 plus 4. You can press enter. And then afterwards, 103 and 4 for the second dimension of the rectangle, and then press enter. And then you should get a rectangle that looks like this, as you can see in the bottom corner. And then finally, rename your sketch to bottom. So I'll go over a demonstration for how to do that. So first, let's see here. This is it doesn't matter which side you make the rectangle on, but in order to make it, well, if you want to follow along, this is bottom side is the shorter side, which is 90.5 plus 4. And this side will be 113.5 plus 4. So then you should get a rectangle that looks a bit like this. When you're done with a sketch and you don't want to alter it, then you can just press this green arrow key. But since we will want to rename the sketch, if you go to the sketch bar, this top right corner, and click this pencil button. Oh, you can't edit it. Okay. How do we type? Okay. So, okay, let me go over this. So, if you manage to get out the sketch box format thing, you go to the top left corner and you click sketch. You click on the sketch, and thus you can re-enter the sketch now that you've made. And how do you type the dimensions? I can't change it. Okay, so to answer your question, Darko, you can press D, which is this button over here, which is dimension. This will then allow you to go and click on one of the side lengths for the rectangle, and this will allow you to alter its dimensions. Now, it's important to note to not over-constrain the box. And what that means is basically, if you try to say, for example, set the two edges of these blocks to something that obviously can't work, which is like 50, and one of them, it'll have this giant red sign and show that there's an error. It just won't allow you to create an impossible dimension for the box. I hope that helps. And then if you want to alter the name, you go to the top left box, you click bottom, and yeah, that'll change its name, as you can see in here, from instead of sketch 1 to bottom now. And when you're done with the sketch, you just click this green arrow. Or you can just click off the sketch as well. But again, if you want me to slow down, or if you have some questions, then feel free to either put it in the chat or just simply say it. So now we will go and make it into 3D. So we'll now create the box of the walls by using the offset tool. So we will offset the one in the we'll offset the I can't, I'm using a trackpad. My box is about 10 miles long somehow. I give okay. So to help you, if you click on the sketch, so first thing first, be sure your workplace units are in millimeters in order to be sure it's not 10 miles long. Afterwards, I want to remind you that if you use the middle mouse, you should be using a mouse. So if you want to scroll in and out, you scroll the scroll wheel on your mouse, which is the middle one. And now you can go, and now you can make things bigger or smaller. So of course, if you're very zoomed in, something may seem very big, but these are units. Also, if you want to ensure that your box is not too big, it's not bigger than it's supposed to be, remember you can always dimension, which is using the keyword D, to set dimensions of the dimensions of the box to some millimeters. So now, using the offset tool. Well, what offsetting something is that it'll basically, depending on what type of offset you do, create an object that's either bigger or smaller than the object you have than the thing you are offsetting. So to give you a demonstration of this, this probably doesn't make too much sense. Click on the four sides of the rectangle. And now click on the offset tool, which should be, sorry, this takes a while to find. Wait, I can just search. I believe that should be the one. Okay. Oh, okay, you can just press O. All right. If you want to offset something up, you could just also press O, I think. That's not how it works. Well, I'll find it one of these days. Loft, extrude. Sketch tool. Oh no, it is okay. Okay, my bad. So so offset is a sketch tool, so you need to double click on the sketch again, and then you can finally offset it. If you want to click the things you're trying to offset, you just click on all the edges of the box. And since we want to make the offset larger than dimensions, drag the arrow, which is this arrow you see, and set it to 4 millimeters. Let's see here. This will create a box that's 4 millimeters larger than the current one that you created. And then after each, you can press escape, or you just click outside of it to conclude the tool. And now this will be the walls of our battery box. Is everyone following? Well, okay, so now that you've created the sketch, which, let's be honest, doesn't look like much, now I'll show you the magic part of this. So, to go from a 2D, well, first we'll add some screws. So, first select the center point screw tool in the sketch. So, again, go to your sketch again. And now click the center point circle. You will then drag your mouse out and click. You will now click on the sketch plane to determine the center of your circle, and then drag your mouse out to enter 4.2 millimeters, which is the dimension of our screw hole. But still, I can't view or review sketch. Okay, good. Alrighty, so if you can't view the sketch, there is this button next to the sketch, if you can see here, where if you press this button and the eye is closed, then that means you've hidden it, so you can't actually see it anymore. If you click this button again, it'll allow you to see it, and if you double click this bar, it'll allow you to re-edit the sketch again. So now you can click the center point circle. For now, it does not matter where you put the center point circle, since we will dimension it later. And and be sure you dimension this thing to be 4.2 millimeters. So again, click D. Oh, E, D, and then afterward, the dimension can be added to a curve in one of its. Technology. Okay. 4.2 millimeters. And as you can see here, this should be the radius, I believe. Unless if I'm wrong. Diameter. Oh. Alrighty. So when you dimension this circle after you've created it, be sure to press D. And now that you dimensioned it, you can now get a circle with a diameter of 4.2 millimeters. Afterwards, you will then click the dimension tool, which is .ud, and you will then select, and then you will then center your circle on the side of the inner rectangle to decide what you are dimensioning it to. Drag and click it to set the dimension in place and enter 8 millimeters as your distance. So if you go here, you can click from the center of the circle to each side of the inner rectangle and go to 8 millimeters. Dimension. Oh. Dimension 8 millimeters. And now you've created a circle that is 8 millimeters within an that is both 8 millimeters inside from each of the sides of the inner rectangle. Still it doesn't even show the eye symbol. Does your top, okay. Perhaps if you could screenshot and send a screenshot in the chat, that might help me help diagnose your problem then. If you could do that, that would help. And give you some advice. So now that you've mentioned it for both sides of the rectangle, we will now use the linear pattern tool in order to duplicate our screw hole. Now, this is a good trick you should employ, since it allows you to save a lot of time CADing this stuff. So if you go back to your sketch, you can click the linear pattern tool, which is over here. Now, click the circle, and then you will see suddenly there will be more circles popping up. Make sure that you have 2 circles in each direction. Click the arrows to drag the arrows so that the screw holes are in the box space. Oh, okay. Well, let me go help you. Oh. So, well, can you click the sketch box on over here? Can you click the sketch? Alrighty. And you still can't edit anything. Like you've double clicked this sketch. Um, um, hmm. So double clicking this doesn't work. Have you tried refreshing your website? Maybe just refreshing it. I don't. It shows properties. Have you tried left double clicking it instead of right? Actually, I don't think that should make a difference, but no property, just the thing you just had to open. Well, that's strange. And I can't interact with the box. Well, if everyone will be okay, could you share your screen so I can help you then, Luca? I'll end my screen share and I'll let you screen share it.
All right.
Yep.
All right.
It's just the green button in the bottom.
No, I know. I just have to
great.
do. Oh, it's not. For sure.
The screen share isn't working.
No, I have to just change my settings on my computer because it's locked.
Okay. Great then.
Yeah, you can keep sharing. I'll be back.
Oh, okay, great. So
Computer's cluttered.
Your screen, battery holder. Alrighty, great. So then afterwards, yeah. So now click on the linear pattern. Be sure you have 2 circles in each direction. So now there should be twice the amount of circles, and type 96 millimeters and 80 millimeters respectively for distances between your holes and robot. So back to here. Put those distances. Back. Choosing that point. Or connection. Huh. That's not good. I'm sorry, I seem to have some internet problems. Not much I can do to help that. Great then. Now that you've gone here, alrighty, so now you will have the linear pattern. Click this circle, and now you've created 2 more circles. Maybe this is not the correct. Let's search the pattern already. Well, now that you have 2 times the circles, now you will be sure. Now be sure to go and click the dimensions of it, which is 96 millimeters and 80 millimeters. So lengthwise, it should be 80 millimeters. It's not. Linear pattern. Just a circular pattern, you know. No. Oh. Oh, I bet. Um. Alrighty. Now that you've got this. So now you've gone down to here, and now you've gone over 8 millimeters. And this one should be 96. Right. Why is it doing so many entities? That's strange. Two-layer patterns. Oh. Be sure these multipliers in the bottom corner are set to 2, so that you only have 2 corners. And now this should be set to 96 and set to 80. I apologize for my technology struggles.
And I have to quit and rejoin for allowing screen share.
Oh, that's okay. Well, hopefully now that you have these types of hopefully now that you have the marks, now you can go press the green check mark, and now you'll be done with the current sketch. And now comes the exciting part. So now you can use the extrude tool. So select the extrude tool, which it will be over here, and this will allow you to really transform your 2D drawing into a 3D one. So click the base, which is of the inner 4 dimensions, and allow it to go to a depth of 4 millimeters. So now you can see you've successfully now made your model 3-dimensional. Now a box. And be sure you don't click on any of the circles, otherwise you'll accidentally extrude the circles that's meant for screws. Now that you extrude, the bottom sketch is hidden. You can now unhide it. Well, okay, well, it should automatically hide the sketch after you extrude it, but in order to unhide it, you go to this part, look at the eye, and open up the eye now, so you can now see it.
All right, I can share now, I think.
Oh, okay, great. Well, okay, let me just complete with this first part, and then you can share. How about that? So extrude the outer wall with the bottom sketch, and now the depth should be set to 43 millimeters. So extrude this once again, click these outer walls, and now go to a depth of 43 millimeters. So as you can see now, you've created this type of box for your battery to be in. So Okay, now I'll try to help your technical problems. Everyone else, please try to job with thing. So okay, now you can share now, Luca. Hopefully I can help. Alrighty, so can you double click the share the sketch one? Yeah, okay. Now go to the top right corner. I mean top left, my bad. And now you can press the box, the rectangle looking thing. Yep, corner scheme. Yep. Oh yeah, you may want to click this. You want specify the sketch plane, which is the top plane. Do you see in your top right corner? There's a little box. No, top right corner. There's a little box. No, the one with the top front right, I think. The one below, the one, yep. And you click top, yep. And now that should let you, if you want to recenter yourself, do click the top again. Yep. And now you can just set, now click the screen anywhere. You just need to click 2 points on screen. Yep. And now afterwards, you can then press the dimension tool, or you can just, if you want to escape the current command, just press ESC. Like press the escape. Yep. Alrighty. If you want to delete that, just click on the node and delete it. Don't drag it. Just click it once and now delete it. Well, the line. Click the line. Yep. Yep. Delete. And you can also click the dot and delete it. And you can click the other dot and delete it. Okay. So, Control Z. Or you can just draw another line, which is if you go. Yep. Okay. Great. Now that you've managed to successfully go to here, now press D in order to figure out the dimensions. Yep. And as you can see in the chat, it should be 90.5.4 and 113.5 plus 4. So now that you dimension it, click on the dimension. Yep, no, click it. No, just click off the screen. Oh, yep, click. You can just click it now. Yep. No, you don't. No, click on the. Yeah, no, just click in the where we're currently placing it. Yep, great. And now you can alter it. So now do 90.5 plus 4. Oh, also you're in inches, by the way. So if you don't know how to set your workspace units, go to the top right corner. And now go to the 3 bars. Yep, click that. Now workspace units, yep. And now set the default inch unit to millimeters. Yep, great. And now just press that, yep. So now you can now dimension. So now double click on the sketch again. On the top, and in the right corner, right bar, now double click on the sketch. No, below. Yep, double click that. Great. And now you can go to the number. No, below. You see the number that shows the how much the side is. Yep. Now change that to 90.4, not inches, because you see in the right side there's for millimeters. Yep. Now press enter, and it'll be a much more normal size. And then all you have to do is dimension the other side as well. Just press D, or there's a shortcut for dimension. Oh. And then you press D, and then yep, now click the side. Yep, and now you can go up. Yep, and now you can press 113.5 plus 4. Yep. Oh well, you don't have to. And then you can just don't have to press plus 4. Yep. Okay. And again, if you can go again, you can always go to the top right box to go and reorient yourself so that it's to reorient yourself to the top face. Yep, great. And then after that, yeah, then you can just continue on with the rest of the lesson, I suppose. You can go to the offset, for example. Oh, okay. And you can just follow along.
Was I not
Yep.
supposed to end the screen share too early? Or
No. You can go back to screen sharing.
all right.
Battery box holder, share that. Great. And I believe now you have the adequate skills to be able to continue on. If you want, I can just share with you the PowerPoint, or would you like if I shared with you the PowerPoint?
What?
Would you like if I shared with you the PowerPoint so you can continue on?
Yeah, I would.
Oh, great. Anyone with the link can access it. Is there a way I can set the screen share options? Guess not. Alrighty, well, I'll go. Well, here's the link to the slideshow. Please don't alter it. Please don't alter it accidentally. But if you go to there, you should be able to go and see the 2021 Onshape class, and you can just follow along with it. If you're behind, you can just follow along with the slides. So, you offset the box, you now put the center point circle, and now we've gotten to the part where you've created this 3D-dimensional box. So, you may want to mount something to the side of it reasonably in order for you to mount it onto a robot. So in order to allow that, you want to cut some holes according to the Go Build quad block pattern. So create a sketch on the walls, rename the sketch to side. So here's your current bin looking thing. You go to the right. Doesn't really matter. Now you will create a new sketch. Yeah, we have to create a point sketch. Yep. Okay. So now you want to create a sketch, and now you'll want to create this on this. If you click the side of this rectangle, it'll create a sketch on it. And once again, you create another center point circle. Now afterwards, you can dimension the center point circle by using again, be sure to always dimension your things. It doesn't sound that important, but it saves you a lot of effort, since it's a lot easier than having to fiddle around with just nudging a circle with every single millimeter. Then afterwards, use the horizontal constraint to be sure it's connecting to the screw hole, is that the point is horizontal. Now these are constraints now. Which one is the horizontal constraint? Okay, good. So now here's the horizontal constraint. Now, you may be wondering, why should you constrain these things? Well, let's see here. What am I horizontally constraining this to? Create now horizontal constraints so that the line connecting the screw hole and the point is horizontal. Okay. So the point of constraining things, and this wasn't covered, is to be sure that when you scale up or down your project, so that it scales normally in the way you expect it to. So if I make this thing so like the dot. Well, for example, if I want to say go to this sketch, go to this bottom sketch, and if I want to go and say, I don't know, make this thing just twice as big. Like if I set this dimension to say, I don't know, 113 or something crazy like that, it will extend it. It'll extend the thing. It'll extend the sketch in the way you want it to, instead of not. So this is a good example of why you always should constrain. If I set this to say now some crazy length, if I now do it, you'll realize that all my current steps, such as the extrusion and everything like that, they all also change with the change in dimensions, which makes it much quicker than having to go and change, then realizing you screwed up on say maybe the dimensions you got it 1 millimeter off. Now you have to go through all these steps again. No, you can now just change one simple detail on your sketch, and it'll change everything accordingly. So that's why you should always dimension. Just makes altering these things so much easier. So now going back to the sketch, right? side, circle, 4.2 millimeters. Now horizontally constrain this, which name would imply constrains it horizontally. And you constrain it to a point. So midpoint, dimension, concentric. Oh yes, so here's a point. Exactly as it sounds like, it's literally just a point. And you can now constrain this horizontally with the point. And now you can tell that these two, no matter how much you change it, let's give you an example. No matter how much you may like to move this, you'll realize that these two will always remain horizontal to each other. They will never at any point not be. And this helps make altering these things so much easier. Again, it's just meant to allow you to alter your sketches with far more ease than you normally would. And now you want to ensure that your hole, I believe, judging by the dimensions, is 21.5 millimeter, I believe, off the ground. So dimension, this. Wait, no, that can't be right. So now you can add extra mounting holes. Oh, yes. Alrighty. And now be sure that the distance between these two are this and this are let's see here. Now, if you look at the dimensions for this, you can figure out the center to center point distances for all of these graphs. Let me read this to figure out what it is. 2.5 millimeters. Okay. Seem right. So now you can use the circular pattern tool. So select the circle and you will see multiple circles that are revolving around the point. So as you can see, instead of linear pattern, you can go down and now you can go circular pattern. Circles. You can see multiple circles already. So now select the circle. Here you go. And now you'll see multiple circles around that point. So see here. Circular pattern, circles. Now you'll see multiple circles. Drag the point until it coincides with the point that you just created. You will know that it happens when you see the coinciding constraint with the icon. So first of all, we want to create 4 circles. So change this 3x to 4x in order to ensure that you now have 4 circles. And now be sure to coincide it and drag this to coincide with the this point. I think I accidentally mentioned this wrong. This should be 16, this should be 20, this should be 24. Change the degree measure. Be sure this degree measure here is 2070 degrees. And wait, no, it's not this. That's supposed to be 21 millimeters. It's escape. Dimension. This is supposed to be 20.5. That's 5 and already circular pattern going to here. Move this center point to reflect this. And then afterwards 4. Great. And yeah, just press enter and it should create it. Great. And now you can just create 4 circles. Lovely. And then dimension the left point as we've created. So see here, dimension. Nope. Rendering capability performance detected. I wonder what that means. I'm sorry if this is somewhat boring. It's not the most interesting thing in the world. Okay, so now you've got these four circles, and now they're all connected in this pattern. Now that I mentioned the point, left click to conclude the tool. Now, right click, yes. We have created. So now you just need to set all these dimensions. 4.2 millimeters, 16. Range. Change this. Millimeters, great. Well, then afterwards, you want to duplicate this. So select the line construction tool, hover over the top of your square until you see the little square indicating that the point is the midpoint of the battery stocks. So here you go. And then afterwards, you get this midpoint. Comes slightly yellow, and then this will show it's a midpoint. Like that. I don't want this point going on here. And then you want to swing it until it has this yellow marking, and it should snap into place. Okay, great. But now you've managed to successfully divide your thing into two. I don't think I'm dimensioning this correctly. Oh. Then afterwards, you'll learn how to use the mirror tool, which is just mirror here. Select the sketch. You can select. So then afterwards, this mirror line is that you can then select the line you've just created. And then now you can select what entities you want to be mirrored on the other side. Like a real mirror. So now after you've selected your mirror tool, now you can select all four circles, and now you've created successfully the mirror to the holes. I don't feel like this dimension is correct. Escape, delete, mention, 16 millimeters. Strange. Well, then afterwards, you can then add slots in your sketch in order to go and allow for a Velcro strap to be secured to your thing. This is not everyone will have a Velcro strap, so it's maybe understandable why this is not the most common feature. But assuming you want to assuming you do want to have a Velcro strap for attaching things, I'll just teach you how to use a slot. So use the yellow. So use the line tool to create a line of length 32 millimeters. Make sure that you see a yellow blue line to make sure it's horizontal. So use a line tool. Be sure that oh yeah, I should bring this. If you see the line go like this color, where you can see it goes yellow, blue, yellow, blue, yellow, blue, and it should just kind of snap into place. This shows that's horizontal. The line is horizontal. Now, afterwards, dimension this 32 millimeters. Now, afterwards, you want to create a new line, since you don't. Now, press escape afterwards in order to go and get out of the line making tool. And now you can use the slot to create a slot 2.5 millimeters away from the slot. So you go off to this offset tool. Below it, you can get slot. Click this line. And you don't want this to be as big as it shows. So 2.5 millimeters. And afterwards, you nope. Yeah, was that? And afterwards, you dimension it. Dimension, great. 20 millimeters off the center of this. Now let the dimension be 20 away from the bottom of the battery box. Click the symmetric constraint and then the two endpoints of the line. Then select the center line or slot center. So in order to ensure that it's symmetric, just like this, click this, click this, and now we'll center it automatically. Also, yeah, the sketch doesn't quite seem right. Out the distance. Well, now you need to press the, now you can then extrude this again in order to go and make these types of holes into real ones. So I think I may have screwed up and accidentally did 16. I think this is supposed to be 8. That's if I'm sorely mistaken. I need to double check the actual blueprints. But okay, well, first, hopefully everyone is following along so far. I just want to confirm that. Yeah, I'm sorry if I'm rambling on. This is not exactly the easiest thing for me either. So I'm sorry if I made these instructions a little difficult to understand or anything. So if anyone has any trouble, then just tell me in the chat. So now we will go into the extrude tool. So now you select the holes and slots and be sure to use the remove tool of the extrude. So again, if you need any help just to search up something, you can just click it and it will just, and if you want to just add any tools, it'll just simply go and find it. But for now, you'll just use extrude. And as you can see, a subcomponent of it is remove. This will now remove, well, as the name would imply, it removes things from the object. So you just click all the areas you want it to act as a drill, basically, to remove. Sorry, my computer is a bit slow. And then afterwards, you can go to the top face of the option, bottom. And now you can go to the top face and so you can get a clear view of what this actually will do. So as you can see, this will basically have this to be, imagine this to be like drill holes. And now that you've gotten these images, if you go through this object, this wall, it will now create these drill holes. See a bit in real time. See, as I go back, if you go through these whole objects, it'll then create them through the box. Then first you press the little green arrow to confirm your decision, and now you can see that you've created these holes in the box and Velcro straps. And now you've managed to make a battery box. Now I understand my presentation. This is probably not the best. So if anyone has any questions, feel free to ask me in the chat or just say it out loud. Since I think we're running a bit over time, if you would like to see how if you would like to learn how assembly works, then do try to post in the chat. Would you like to learn assembly? Given our remaining time? Slideshow. Anybody? Have you all fallen asleep in my lecture? Should be a possibility. Well, I don't know if you can hear this or not. So I'll just go over some other features you can do. So we talked about feature scripts previously, so I should just teach you. So this is some real cool stuff you can do outside this battery box. So if you do add custom features, here you can do some feature scripts. And one of the nice ones that you can do spur gear. Spur gear. And then if you want to click on, say, if you just want to make a spur gear with 20 teeth, you can just click on spur gear with range. Feature, feature scripts, other documents, spur gear, copy of spur gear. Yep. Be how it works. Here, custom features, robotic parts, feature script samples, spur gear, custom feature. Yep. Okay, great. Spur gear. And if you just want to create a spur gear, then it'll just create a custom spur gear. And create custom feature, research samples, spur gear, custom feature, and spur gear. Yep. And now you can click spur gear. Okay, great. And now you can create a gear. Probably should move this out of the way. But it creates it at the dimension at center. You can fiddle around with these instructions such as the pitch angle, circle diameter, module, etc. And then afterwards you can create quite easily a spur gear. And if you want to move this, just and as you can see, you can create quite easily just create a spur gear with however many teeth or whatever features you wanted to have. And you can also do other things. Again, with gears, they're the depth, how thick you want it to be, the number of teeth your gears will have, the pitch diameter you want it to have. The module, how you want to make a helical, or if you don't want chamfer, center bore. You probably, I don't know how much you actually care about gears, but well, these are just the things, these are just all things you can do with them. And I'll just cover, and here's just a quick covering of constraints. So these are quite important. If a sketch is blue, that means you can move it around and move it to multiple positions. If it's black, that means you fully constrained it. If you've successfully managed to go in and CAD something, hopefully your sketch should be completely black, because that means that everything is constrained, and that means that when you adjust one feature of it, everything else should adjust as it should. So, and that also means that you defined all the dimensions for everything. So you can't tell exactly what it will be, but these are some constraints. So coincident basically makes the two selections coincident, coincident. So So let me just go and give you an example. Oh. So allow me to go and give you an example of this. So let me just go and create two circles to demonstrate all these constraints. So as you can tell, these are blue circles. You can move them around as you please, make them bigger or smaller. The point, you can shove them around wherever. So if you want to make these two coincident, meaning that they will touch each other, yeah, these two circles will now become coincident. Now, of course, these are circles, so they kind of make the two the same. But well, maybe this will be maybe if I just come, yeah, okay. So you can tell now that I've constrained these to be coincident. Now, if I want to move this around, it can only be moved around the larger circle, somewhat like an orbit, and it'll always be adjusting to be sure that these two are coincident with each other automatically. Tangent, make sure that they're tangent with each other. So just go back and concentric tangent. Okay, this tangent here, click D2. I'll always be tangent. Move these circles around, automatically adjust it. Inwards, move it smaller. Be sure they will always be tangent to each other. Then afterwards, a vertical, which will make the two of them vertical with each other. So click these two center points. And now one will always be on top of and now they will always be on top of each other. Horizontal. As you've already seen, it'll make them be in the same line. Nope. Yep. And equal, which will always make their dimensions equal to each other. So if I want the two to be the exact same size, click on their outer radius, and now they will be the exact same size. And of course, you can check this by going to the bottom right corner. It'll show measure details, and you can just click on these two. And you can see that this one will have a diameter of 46.648. Don't really care about it. And this one will also have a dimension of 68.48. So, yeah. Always important to constrain things. So, thank you for coming to this meeting. Do check out our Gmail or our Instagram at FTC21229 or our YouTube video, or our YouTube channel, which is FTC Quality Control. Do we have time to cover assembly? If you'd like to learn assembly, then please stay on. Do any of you two organizers know if we have time?
I think that's all for this workshop. Sorry.
Well, then don't worry about it.
Yeah,
Well,
thank you so much, Eric.
yes. It's a pleasure.
Yeah, thank you for coming.
Yeah. Well, bye then. Thank you, everyone. Again, please check out the Gmail and Instagram and YouTube. Well, bye then.
Bye-bye.
See here, stop video, stop share.